All right, today um we're gonna talk about let's do that how to use my math lab. Um you just sign in, click on this is a remote, so you math 127 spring, and then this is what you do. You click on do homework and quizzes, and you see 6.2, these are due next. And then you could also click on guided lecture notes. You have study plan, depends on what section you are in. Okay. uh then there are videos you could watch. So for example, we're in 6. See, there are videos right over here. You could watch these videos. um and that's how it goes. All right, let's do trig properties. So today we're gonna look at uh, domain, range, those type of things. We're gonna look at domain, range, and period. All right, first thing first, let's look at period. A function f is called periodic if there is a positive number p such that whenever data is in the domain of f, so is theta plus p, so is theta plus p. So therefore f of theta plus p equals f of theta. So using that understanding, sine, cosine, all the trig functions are periodic, okay? So for sine, the period is theta plus 2 pi, which is sine of theta. So periods for sine, cosine, cosecant, and secant is every 2 pi. Is every 2 pi. So if I give you some problem, something like that, sine of 17 pi over 4, and we're going to use the information from last lecture. How many 2 pi's are in here? So let's look at it. 17 pi over 4. Well, in order to see 2 pi's, this doesn't look like 2 pi. So we got to convert the 2 pi into something, convert 2 pi into something over 4. So if I want to convert something over 4, I need to get, 8 pi over 4. Because if I simplify that, it is 2 pi. Now we got to ask ourselves, how many 8 pi over 4 do you have in here? 8 pi over 4 plus 8 pi over 4 plus 3 pi over 4. So when I add them, I get 17 pi over 4. So therefore, I could rewrite this problem as 2 pi plus 2 pi plus 3 pi over 4. And what do we learn? Since they're periodic, this will have the same answer as sine of 3 pi over 4. So we could get rid of this extra information. Now, how do we go about solving 3 pi over 4? Let's ask ourselves, where is 3 pi over 4? 3 pi over 4 is in the second quadrant. That's 3 pi over 4. So what's the reference angle in this case? So the whole thing is pi minus 3 pi over 4, and you get pi over 4. So the reference angle in this case would be pi over 4. Now, is sign positive or negative in this quadrant? It's positive in this quadrant because all student takes classes, and that's how we get this. So now we go back to our table, and sine of pi over 4 is positive square root of 2 over 2. Let's do another problem. Cosine of 5 pi, what would that be? Again, the period is 2 pi. So right away I could write it as cosine of pi plus 4 pi. And 4 pi is redundant, so we just look at cosine of pi. Well, we know cosine of 0 is negative. Sorry, cosine of 0 is 1. And all students takes classes. So cosine is positive in this quadrant, first and the fourth quadrant. Pi is in this quadrant right over here. So cosine is going to be negative. So we get negative cosine of. That's the reference angle, and you get negative 1. So let's do some kind of word problem. If sine of theta is greater than 0 and cosine of theta is less than 0, name the quadrant in which the angle theta lies. I'm sorry. Cosine of theta. So in this case, we ask ourselves, sine of theta is greater than 0. That means theta is positive. And cosine of theta is negative. And cosine is negative in these quadrants. So where do they overlap? Right over here. So theta is in the second quadrant. Let me give you a little bit more. Remember I told you sine of theta is the reciprocal of cosecant. So let me give you some other properties. Cosecant of theta is equals sine of theta. Secant of theta equals 1 over cosine of theta. And cotangent of theta is 1 over tangent of theta. We also know that since tangent of theta is sine over cosine, cotangent of theta would be cosine of theta over sine of theta. All right, now let's do some hard problems. Given sine of theta is square root of 10 over 10, and cosine of theta is root 3 over 10. I want to know what is tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Well, I just gave you that the reciprocal, cosecant is the reciprocal of that, so it will be 10 over square root of 10. This would be 10 over 3 root 10. Tangent is sine over cosine, so you just get 1 over 3. And cotangent is just the reciprocal of that. Now, the following one, we're going to use this over and over again. It's very crucial. Sine square of theta plus cosine square of theta equal 1. From that, we arrive two other properties. Tangent square of theta plus 1 equals secant square of theta, and cotangent square of theta plus 1 equal cosecant square of theta. Guys, if you missed my lecture again, you could go to my channel, click on Math 127 Play, and I have videos on them too. Okay? All right. Let's answer this one. 1 cosecant square of 35 degree plus cosine square of 35 degree. What would that be? Well, we know what this is. The reciprocal of reciprocal is what? 1 over sine square of 35 plus cosine square of 35. This just goes to the top. Sine square of 35 plus cosine square of 35. Well, and then I could use this property right over here. It tells me it's just 1. All right, let's do some little bit of hard one. Sine of theta equals 2 over 5, and cosine of theta is less than 0. So I gotta find cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. For that, we're going to make a triangle. All right, so for this one, we're going to use a triangle. So it tells us that sine of theta is positive and cosine is negative. So what quadrant are we talking about? Sine is positive and cosine is negative. So we're talking about this quadrant. So let's make this triangle right over here. And that's your theta. And it tells me that sine of theta, and we're going to use SOHCAHTOA. SOHCAHTOA. Sine of theta tells me that opposite over hypotenuse. So we have sine of theta equals 2 over 5. So it's opposite is 2, 5 is hypotenuse. Can we find the missing side? Yes, we can. All we have to do is that x squared plus 2 squared equal 5 squared. So x squared equal 25 minus 4. So x is 21, okay? Now, we got to ask ourselves, is this negative or positive over here? X-axis is negative, so therefore is negative square root of 21. So now the problem is super easy. Using this triangle information and SOHCAHTOA, we can figure out what's happening. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, TOA. And then right now it's super easy. They're just reciprocal of that. It's that simple. All right, let's try another one. This is a hard one. Cotangent of theta equals 1/3 and sine of theta equals less than 0. So we gotta find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Well, cotangent of theta is 1/3. Tangent of theta is 3/1. It's that simple. So I'll give you a little bit time. So figure out what quadrant it is in. Okay, so I give you, so cotangent is positive and sine is negative. So tangent is positive in this quadrant and sine is negative in these quadrants. So therefore, the triangle is gonna lie in the third quadrant. So tangent says, this is my theta, opposite over adjacent, okay? Now we have a problem, opposite over adjacent. Opposite over adjacent, look at the x and the y value. They have to be what? there are y is negative, x is negative over there. And it kind of makes sense because negative over negative is positive, and that's how we get this positive answer. Now, can we find the missing side? Yeah, negative 1 square plus negative 3 square equal h square. So you get 1 plus 9 equal h square. So we're looking at square root of 10. So now we have completed the triangle. So therefore, sine of theta would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And the cosecant and secant are the reciprocal of that over 3 and negative 10. All right, this one is a little bit tricky, and most of you guys forget that. But this comes back over and over again. Even, odd properties. So I'm just going to tell you that sine and tangent are odd, and cosine is even. And what does it mean to be even and odd properties? When you're odd, sine of negative theta equals negative sine of theta. So you see the negative? Just negative comes out. Same as tangent of negative theta is negative tangent of theta. To be even, cosine of negative theta, the negative goes away. It gets absorbed. And you get the function by itself. So for example, cosine of negative 60 degree is same as cosine of 60 degree. And we know what cosine of 60 degree. We use that table, which is just 1/2. Okay, alrighty then. This will conclude my lecture. If you have any question, you could ask me the question in YouTube channel right now, or I'm in my office. You could call me directly to my office right now, 702-651-5832. 702-651-5832. All right.